Hello and welcome. This is Organic Chemistry 2 Review 2A.2, and it's presented to you by Science Visualized. Number 5. Provide the multiplicities of the protons at position A, B, and C. So remember, when you're looking at multiplicities, we're looking at n plus 1, where n is the number of non-equivalent protons on the next carbon. So it's the number of hydrogens that are in a different chemical environment from the hydrogen that you're looking at. So if we're looking at A, that's a CH3, and then the next carbon is here, and that is actually a CH. It has only one hydrogen. So in this case, for A, n plus 1, n actually equals to just one hydrogen plus 1, and that gives you 2, which will be a doublet. And remember, doublet, the ratio is 1 to 1, so you split into equal intensity, equal heights. Number B, so we're looking at that CH3, and that CH3 has only one neighbor right there, which is a CH2. So that means the value of n is the number of hydrogens on the next carbon, which is 2. So n plus 1 equals to 2 plus 1, which equals to 3, and that will be a triplet. Using Pascal's triangle, the intensity is going to be 1 to 2 to 1. So that's going to look like that. Then last, number C, that one has several neighboring carbons. I'll call this M, N, and O. So M is a CH2, so has 2 hydrogens. O is a CH2, has 2 hydrogens, and N is a CH2, has 2 hydrogens. So basically you end up adding all the neighboring hydrogens, and that makes a total of 6. So N is actually 6. N plus 1 equals 6 plus 1, which equals to 7, and that's called septet. And that's a more complicated splitting pattern. You can just call it a multiplet.